Okay, today we're going to be looking at arithmetic progressions. So we've already encountered an arithmetic progression. When we have a linear sequence of terms, such as 5, 8, 11, 14, 17, and so on and so forth. This is an arithmetic progression. We have the first term, which we denote with an A. In this sequence, A is 5. We have a common difference, which we denote with D, and in this case the common difference here is 3, and we have a last term in our sequence, and we denote that with an L. We can also have an arithmetic progression which goes, this is increasing. We can have an arithmetic progression where D is negative, so for example 10, 6, 2, minus 2, so on. In this case D would be minus 4. We can also have an arithmetic progression where D is equal to 0, so say 5, 5, 5, 5. Common difference here is 0. That is also an arithmetic progression. So A is term 1 in general terms. A plus D is term 2. A plus 2D is term 3. A plus 3D is term 4. A plus 4D would be term 5. So the nth term is equal to A plus n minus 1 D. So we're going to do a couple of examples. So a very simple one to begin with. Find the number of terms in the arithmetic progression minus 3, 1, 5, 9, 13, and we've missed a few, and the last term is 237. So the nth term, let's look at the general formula, is A plus n minus 1 D. Now we have, in this arithmetic progression, A equals minus 3, and our common difference D is 4, and the nth term, which is our last term, is 237. So 237 is the term that we're interested in. A is minus 3. We don't know what we don't know what n is, and D is 4. So now we're going to solve this equation. So we'll get n minus 1 equal to 60, so n must be 61. Let's look at another example. The fourth term of an arithmetic progression is 7, and The 10th term is 16. Find the first term and the common difference. So let's think about the fourth term first. That equals 7. So this implies 7 must equal a, which we don't know, plus 3d because it's n minus 1. And the 7th and the 10th term, is equal to 16. So this implies 16 is equal to a plus 9d. So now we're going to call this equation 1 and we're going to call this equation 2. So now we're going to solve them as simultaneous equations. So we're going to take equation 2 and take away equation 1. So that gives us 16 minus 7 is 9, and the a's will cancel, and we're going to get 9 minus 3d is going to give us 6d. So d must equal 1.5. And now we're going to substitute back into 1, substitute into 1, so a plus 3 times 1.5 equals 7, and that must mean a is 2.5. So the first term is 2.5 and the common difference is 1.5. And that shows us as well in this example, that an arithmetic progression doesn't just need to be whole numbers, it can be decimals and fractions. The nth term of an arithmetic progression is 5 minus 6n. Find the first term and the common difference. So the first term equals 5 minus 6 minus times 1 is equal to minus 1. And the second term, 5 minus 6 times 2 equals minus 7. So the common difference must be minus 7 minus 1, which is minus 6. So leading on from arithmetic progressions, we can do the sum of an arithmetic progression, and this gives us an arithmetic series. And if we have the sum of an arithmetic progression, arithmetic series S of n is equal to n over 2 a plus L, where L is the last term, or we can write that as S n sum of the series, the sum of the progression series is n over 2a plus n minus 1 d. Now, let's prove this. So what this shows us is, if we were to, let's look a wee bit at maths history. The famous mathematician Carl Gauss, when he was a child at age 7 or 8, his maths teacher was exasperated with the fact that he always finished his maths problems really quickly. So he was given the problem to add all the numbers between 1 and 100. So, and the maths teacher thought this would keep him busy for a while, and left him to it. But very quickly, Carl came to his maths teacher with the correct answer, and the teacher thought he had cheated, and was quite cross with him. But what he realised was that if you add 1 plus 100, we get 101. If you add 2 plus 99, you get 101. If you add 3 plus 98, you get 101. So what you worked out is, if you add these the terms that are kind of, and work your way back, you can then multiply the number of sums you've got by the 101, and you will get the answer. So this is how you get the sum of an arithmetic progression. So let's look at the general proof. So say we've got our we're summing our progression to get our series. There's our first term, plus our second term, plus our next term, and so on. And then at the other end we'll have the last term minus 2d, plus the last term minus d, the second last term, plus our last term. Now let's reverse that. So it's exactly the same, but it's just in the opposite order. So we'll start with the last term, then our second last term, then our third last term, then we've got our third term, our second term, and our first term. And we're going to add these. So here we'll get 2Sn plus a plus L plus a plus L plus a plus L, all so on and so forth, a plus L, a plus L. Because the d's will cancel, so we just have a plus L, a plus L, the 2d minus 2d. So that then gives us n a plus L, which works out as S. The arithmetic series is n over 2, and if we substitute L for a plus n minus 1d, we get this. Another useful fact, I'll just write this useful thing up here, which is something just to tuck away there because it's useful to pull out when doing problems. The nth term of our arithmetic progression is the arithmetic series of the n term minus the arithmetic series of n minus 1. And we'll use that in a wee while with an example. So let's do a couple of examples for arithmetic series. In an arithmetic progression, the first term is minus 12, the 17th term is 12, and the last term is 45. Find the sum of all the terms in the progression. So we need to begin by finding the common difference. So the nth term is equal to a plus n minus 1d. So that's for our progression, arithmetic progression. So we know that the first term is minus 12, and the 17th term is 12. So we're going to, so n is 17 and that is 12, and 17 minus 1 is 16, and then that's d. So d must be 3 over 2. Now the last term is 45. So we need to find out how many terms are in the whole sequence. We need to find out what n is. So we know that 45 is equal to minus 12, that's the first term, plus n minus 1, and d is 3 over 2. So we're going to solve this, so n minus 1 must equal 38, so n must be 39. So there's 39 terms in our sequence. So now we're going to find the sum of the progression. So Sn is n over 2 a plus l. N is going to be the sum of the 39 terms. So it's 39 over 2. First term was minus 12 plus the last term, which is 45, and that will give us 643 and a half. Let's do a couple more. The 10th term in an arithmetic progression is 14, and the sum of the first of the sum of the first 7 terms, is 42. Find the first term of the progression and the common difference. So we know the nth term is a plus n minus 1d, and the 10th term is 14, so it's 14. We don't know what a is, and it's the 10th term, so it's going to be 10 minus 1, which is 9, and we don't know d. And we know that the sum of the first 7 terms is 42. So Sn n over 2, 2a plus n minus 1 d, so this is for the sum, is, so the sum of the first 7 terms is 42. So 42 is equal to 7 over 2, we don't know what a is, plus 7 minus 1 is 6d. So that's going to give us 6a plus 3d if we simplify all that down. So we're going to call this equation 1 and this equation 2. So again we've got a couple of equations which we can solve using a simultaneous equation. So we're going to take equation 1 and we're going to take away equation 2. So 14 take away 6 is going to give us 8. A and A are going to cancel out. 9 take away 3 is equal to 6, so 6d, so d is equal to 4 over 3. And we're going to substitute that back into the first equation. So that will give us 14 plus a plus, equals 14 equals a plus 9 times 4 over 3, and so that will give us a is equal to 2. So our common difference is 4 over 3 and our first term is 2. One more example. The sum of the first n terms of a particular arithmetic progression is given by Sn equals 4n squared plus n. Find the first term and the common difference. Find an expression for the nth term. So let's think, what is the sum of the first term? So this will give us just the first term, because if it's an arithmetic, if it's the sum of an arithmetic progression with one term, it's going to be the one term because we're only adding one thing. So Sn, where n's 1, will give us 4 plus 1 equals 5. So what's the sum of the next two terms? So that will give us 4 times n squared, so that's 2 squared, plus 2, which will give us 18. Now the nth term is Sn minus Sn minus 1 from previously. So we can find what the nth, when n is, so for n equals 2, we can find what that value will be. So we can do 18 minus 5, which gives us 13. So 13 is the second term. So we know the first, so A must be 5, and D, common difference must be 13 minus 5, which is going to be 8. So that's part A. Now part B, we have the nth term is equal to A plus n minus 1 D, which will be 5 plus n minus 1, 8. Now we can expand the brackets, n minus 8. So it's going to be 8n minus 3. So I hope that helps.